640 light years from where you are sitting right now, something enormous is losing control of itself. It is not a planet. It is not a black hole. It is a star so large that if you dropped it into the center of our solar system, its outer edge would swallow Mercury, Venus, Earth, Mars, and keep expanding until it brushed against Jupiter. For over a century, astronomers have watched it. For over a century, it has behaved strangely, but never like this. In the last few years, new instruments have caught something moving inside it that should not be moving, something ejecting from its surface that should not be ejecting. And the closer scientists look, the more one uncomfortable question keeps resurfacing. Are we watching the final years of a dying supergiant live in real time without even realizing it? Its name is Betelgeuse. You have probably seen it without knowing it. It is the reddish-orange star that marks the shoulder of Orion, one of the most recognizable constellations in the night sky. But what looks like a simple twinkling point of light is, in reality, one of the most violent, unstable, and unpredictable stellar objects known to modern astronomy. And recently, the tools we use to study it have gotten dramatically better. Infrared observatories have started picking up patterns that no one expected. Massive plumes of material being hurled off the star's surface, convection cells the size of solar systems churning beneath its skin, dust clouds forming and collapsing in ways that suggest the star's internal machinery is no longer behaving like a stable, aging giant. It is behaving like something approaching the edge. Here's where it gets complicated, because Betelgeuse has fooled us before. Back in late 2019, astronomers watched Betelgeuse do something it had never done in recorded history. It began to dim, not slightly, dramatically. Over a matter of weeks, the star lost roughly 2/3 of its usual brightness, dropping to its faintest recorded level by early 2020. Headlines exploded overnight. Was this it? Was humanity about to witness a supernova with the naked eye live for the first time in 400 years? Astrophysicists scrambled. Papers were rushed. Telescopes across the planet were redirected toward one single point in the constellation of Orion. And then, just as quickly as it dimmed, a Betelgeuse began to brighten again. The panic faded. The headlines moved on. But here's the part almost nobody remembers. The explanation that followed was almost more unsettling than a supernova would have been. What most people are not seeing is that the 2019 dimming event was not a fluke or a random flicker. According to the research that followed, Betelgeuse experienced what scientists now call a surface mass ejection. Essentially, the star violently expelled a massive chunk of its own visible surface into space. Not a normal stellar wind, not an ordinary flare. Astronomers estimate the ejected mass at roughly 400 billion times larger than a typical eruption our own sun produces during a coronal mass ejection. Read that again. 400 billion times larger than anything our sun does. That expelled material cooled as it drifted away from the star, condensed into a vast cloud of dust, and blocked our view of Betelgeuse's light from Earth. That is what caused the great dimming. Not death, not collapse. A star tearing off a piece of itself and throwing it into the void. But think about what that actually means for a star that is supposedly just going through normal aging. Stars don't usually rip off chunks of their own photosphere. This is not gentle decline. This is not calm, predictable decay. This is a star behaving like something under enormous internal pressure. A system that has begun losing the ability to hold itself together in the smooth, cyclical way it has for millions of years. And that single event has completely reshaped how scientists study this star going forward. To understand why this matters so much, you have to understand what Betelgeuse actually is, because it is not a normal star by any measure. It belongs to a category called red supergiants, stars that have burned through the hydrogen fuel in their cores and have swollen into almost unimaginable sizes as a result. Betelgeuse has expanded to a diameter of roughly 1 billion miles. If you placed it at the center of our solar system, replacing the Sun, its outer atmosphere would extend past the orbit of Mars and reach toward Jupiter. Everything we know, the Earth, the Moon, human civilization, would exist somewhere inside the boiling outer layers of this single star. That is the scale we are talking about. And crucially, stars this massive do not fade away quietly. They do not slowly dim into the darkness over billions of years like smaller stars such as our Sun eventually will. Stars in Betelgeuse's mass class live fast, burn through their nuclear fuel at incredible speed, and end their lives in one of the most violent events the universe is capable of producing, a supernova. This is where the story stops being abstract and starts becoming genuinely unsettling. Betelgeuse is estimated to be somewhere between 8 and 8.5 million years old, which sounds ancient until you realize that our Sun, by comparison, is 4.6 billion years old and only about halfway through its life. Betelgeuse has lived its entire existence from birth to now in a fraction of the time our Sun has taken just to reach middle age. That is because massive stars burn recklessly. They consume their fuel at a rate that guarantees a short, violent life. And astronomers studying its internal structure believe Betelgeuse has already exhausted the hydrogen in its core and moved on to fusing heavier elements, a process that, in stars of this size, does not last for millions of years anymore. It lasts for a comparative blink. Some estimates suggest Betelgeuse could still exist in its current form for another 100,000 years. Other analyses of its unstable behavior suggest the timeline could be dramatically shorter. Nobody can say with certainty, and that uncertainty is exactly the problem. To put that timeline into perspective, consider what short actually means on a stellar scale. Our sun will spend roughly 10 billion years quietly fusing hydrogen before it even begins to swell into a red giant of its own. Betelgeuse never had that luxury. Because it started life so much more massive, gravity forced it to burn through its core fuel at a drastically accelerated rate, compressing an entire stellar life cycle into a window that, cosmically speaking, barely registers. And the final stages of that life cycle compress even further. Once a star of this mass moves past hydrogen fusion and begins fusing progressively heavier elements, helium into carbon, carbon into neon, neon into oxygen, and eventually silicon into iron, each successive stage burns faster than the one before it. The helium burning stage can last on the order of 1,000,000 years. Silicon fusion, the final stage before collapse, can be finished in a matter of days. Read that again. Days. If Betelgeuse has already reached anywhere near the final stage internally, the outward signs, the mass ejections, the pulsation irregularities, the disturbed atmosphere, could be the last visible symptoms before an ending that arrives with almost no additional notice at all. This is where the James Webb Space Telescope enters the picture, and this is where the story shifts from historical context into something happening right now. Unlike earlier telescopes that primarily observed invisible light, Webb was built to see in infrared, a part of the spectrum that allows it to cut straight through thick clouds of cosmic dust that would otherwise block our view entirely. For a star like Betelgeuse, constantly surrounded by shifting clouds of ejected material, this capability is enormous. Where older instruments saw a blurred, dimming star and could only guess at what was happening underneath the dust, infrared observation lets scientists look past the smoke and directly at the fire. And what they have found is not reassuring. Webb's observations have detected streams of matter being violently thrown off Betelgeuse's surface, not in one isolated event like 2019, but as an ongoing pattern. Enormous quantities of stellar material launched outward again and again. The heat signatures researchers are recording, combined with the erratic mixture of gases surrounding the star, point toward a stellar interior that is anything but calm. Something is happening deep inside Betelgeuse's core, something violent enough to be shaking its outer layers loose in massive quantities, and the frequency of these events appears to be part of an escalating pattern rather than a single freak occurrence. But here's where it gets worse. In January of 2026, researchers using nearly 8 years of accumulated Hubble Space Telescope data announced something that reframed the entire Betelgeuse mystery. They identified a previously hidden companion star, a small stellar object orbiting so close to Betelgeuse that it is actually passing directly through the supergiant's extended outer atmosphere. Astronomers have named it Siwarha. It is nowhere near Betelgeuse's size. By comparison, it is a pinprick against a giant, but its orbit carves a visible physical wake through Betelgeuse's outer layers as it moves, disturbing the gas and material around it in a detectable, structured pattern. For years, scientists had puzzled over irregularities in Betelgeuse's behavior that didn't fit cleanly into existing models. Now, at least part of the explanation has a name and an orbit. Think about what that changes. This isn't just one enormous, unstable star behaving unpredictably in isolation. This is a binary system, where a smaller companion is physically dragging through the atmosphere of a red supergiant that is already ejecting material, already pulsating irregularly, and already showing signs of internal instability. The presence of Siwarha adds an entirely new layer of complexity to predicting what happens next, because gravitational interaction between two stars in such close proximity can influence mass loss, alter internal pressure dynamics, and potentially accelerate processes that were already unstable to begin with. Betelgeuse was never just being watched as a solitary object. It has, this entire time, had company, and that company may be quietly shaping its fate. Now overlay that discovery onto everything else astronomers already knew, and the picture becomes considerably more dramatic. Betelgeuse pulsates. Over roughly a 420-day cycle, it swells and contracts, brightening and dimming in a rhythm scientists have tracked for a century and a half. That rhythm has historically been treated as one of the more predictable, stable features of the star. A heartbeat astronomers could set their instruments to, but in recent years, that heartbeat has begun behaving irregularly. The timing has shifted. The intensity of the pulsations has changed in ways that don't match historical patterns. When a system that massive, that old and that close to the end of its fusion lifespan, starts showing irregularities in what used to be its most predictable behavior, astronomers pay very close attention. It's the equivalent of a patient's normally steady heartbeat suddenly developing an arrhythmia. It doesn't necessarily mean catastrophic failure is imminent, but it absolutely means something inside the system has changed. And this is where the story stops being purely scientific curiosity and becomes something with actual consequences for us. If, and this remains a genuine if, Betelgeuse were to go supernova, the event would not be some distant, abstract astronomical footnote. At 640 light-years away, Betelgeuse is close enough that its death would be visible from Earth without any telescope at all. Scientists estimate the explosion could briefly rival or even exceed the brightness of the full moon in our night sky. Some projections suggest it could be visible even during daylight hours for a period of weeks or possibly months before gradually fading. For a species that has never, in all of recorded history, witnessed a supernova this close and this bright, it would be one of the most extraordinary naked-eye events ever experienced by human civilization. Ancient astronomers recorded a supernova in the year 1054 that was visible in daylight for weeks. The remnant of that explosion is now known as the Crab Nebula. Betelgeuse's death, if and when it happens, would likely be more spectacular still, given its comparative proximity. Here's the reassurance, and it matters. Distance protects us. 640 light-years is far enough that Betelgeuse's eventual supernova poses no meaningful physical danger to Earth. There is no radiation threat, no atmospheric disruption, no extinction-level consequence hiding in this event. What we would get instead is a front-row seat to one of the rarest and most valuable astronomical spectacles available to modern science. Real-time observational data on exactly how a massive star dies, how heavy elements are forged and scattered across a galaxy, and how the raw material for future planets, and potentially future life, gets seeded into the cosmos. Supernovae are, in a very real sense, cosmic recycling engines. Every heavy element in your body beyond hydrogen and helium, the calcium in your bones, the iron in your blood, the oxygen you're breathing right now, was forged inside a star that eventually exploded and scattered that material across space. Betelgeuse's death, whenever it comes, would be humanity's chance to watch that process unfold from uncomfortably close range in extraordinary detail for the first time with instruments as advanced as the ones we have today. But here's the sentence that keeps astronomers up at night. Nobody can tell you when. This is not chaos. This is not a lack of data. This is the fundamental nature of stellar death. Supernovae do not send warnings on predictable timelines. A star can show every sign of instability, mass ejections, irregular pulsations, a companion star disturbing its atmosphere, chaotic convection patterns, and still continue in that unstable state for tens of thousands of years before actually collapsing. Or, theoretically, given how close it already appears to be to the threshold, it could happen far sooner than current models suggest. The honest, sobering truth that most sensational headlines skip over is this. Astronomers genuinely do not know if Betelgeuse's core collapse is 10,000 years away or 10 years away. The physics of the final moments before a supernova unfold far too quickly and far too deep inside a star's core for any existing telescope to give us a countdown clock. What Webb, Hubble, and ground-based observatories can do is document the buildup. And that buildup keeps escalating in ways that make Betelgeuse impossible to ignore. Every new observation cycle adds another data point to an already unsettling trend. The 2019 dimming event, once considered a bizarre outlier, is now understood as one visible symptom of an ongoing, violent internal process. The discovery of Siwarha in 2026 revealed that Betelgeuse's instability may be partly driven by gravitational disturbance from a stellar companion nobody had confirmed until recently. Infrared imaging continues to detect fresh streams of ejected material, hinting that the star has not returned to any kind of quiet equilibrium. It has simply shifted into a different, ongoing pattern of eruption. Each of these findings, on their own, might be dismissed as isolated curiosities. Stacked together across just the past several years, they form something that looks less like random noise and considerably more like a trend line pointing toward instability. And this is exactly why the phrase "final warning" carries real weight here, even with all the necessary scientific caution attached to it. Nobody is claiming Betelgeuse will explode next week, next year, or even within our lifetimes. That would be irresponsible speculation dressed up as certainty. But what the accumulated observational data does support is this. Betelgeuse is no longer behaving like a stable star quietly waiting out the final chapter of its main sequence life. It is behaving like a system under genuine internal stress, shedding mass in extraordinary quantities, pulsating irregularly, disturbed by a previously hidden companion, and doing all of this while sitting close enough to Earth that its eventual death will be one of the most significant sky events in recorded human history. The real story is not that scientists have found definitive proof of an imminent explosion. The real story is that the tools available to us have finally become sensitive enough to catch a massive star in the genuine, documented act of destabilizing, something previous generations of astronomers could only theorize about from a distance without ever actually watching it unfold. We are, quite literally, watching the mechanics of stellar death play out in observational data for what may be the first time in the era of modern astronomy, on a star close enough and bright enough to study in extraordinary detail. That alone is historic, regardless of exactly when the final collapse occurs. Consider, too, what this means beyond Betelgeuse itself. Every red supergiant in every galaxy will eventually reach this same threshold. Every one of them will, at some point, begin shedding mass, developing irregular pulsations, and showing the exact signatures astronomers are now cataloging in real time on Betelgeuse. Because Betelgeuse happens to be close enough and bright enough, and positioned in a constellation every stargazer on Earth can identify without effort, it has become the ultimate case study, a live laboratory for understanding exactly how these giants transition from stable fusion machines into unstable dying systems on the verge of catastrophic collapse. What scientists learn from watching Betelgeuse will directly shape how they interpret every other unstable red supergiant discovered across the galaxy for decades to come. Consider, too, what this means beyond Betelgeuse itself. Every red supergiant in every galaxy will eventually reach this same threshold. Every one of them will, at some point, begin shedding mass, developing irregular pulsations, and showing the exact signatures astronomers are now cataloging in real time on Betelgeuse. Because Betelgeuse happens to be close enough and bright enough and positioned in a constellation every stargazer on Earth can identify without effort, it has become the ultimate case study, a live laboratory for understanding exactly how these giants transition from stable fusion machines into unstable dying systems on the verge of catastrophic collapse. What scientists learn from watching Betelgeuse will directly shape how they interpret every other unstable red supergiant discovered across the galaxy for decades to come. There's also a human dimension to this that rarely gets discussed alongside the astrophysics. Betelgeuse has been named, mapped, and mythologized by nearly every civilization that ever looked up at Orion. Ancient Egyptian astronomers associated the region with their afterlife mythology. Aboriginal Australian sky traditions built entire seasonal calendars around Orion's position. Medieval Arab astronomers gave Betelgeuse the very name it carries today, derived from a phrase referring to the hand or shoulder of the giant. For thousands of years, across cultures that had no contact with one another, human beings independently looked at the same reddish point of light and built stories around it. None of them could have known that the object they were naming was, even then, quietly burning through the final chapters of its existence. That thread, from ancient sky watchers assigning it meaning, to modern infrared telescopes measuring the exact composition of gas being violently ejected from its surface, is part of what makes this particular star different from the thousands of other dying giants scattered across the galaxy that nobody will ever notice. Betelgeuse is not some anonymous object in a distant, unnamed catalog. It is one of the most recognized single points of light in the night sky, and it may be actively dying in front of us. So where does that leave us? It leaves us in a strange, suspended position, watching a star that could be entering the final visible chapter of a life measured in millions of years, armed with better instruments than any generation before us, and still fundamentally unable to answer the one question everyone actually wants answered. When? Astronomers will keep watching. Webb will keep collecting infrared data. Hubble will keep tracking Sawara's slow, disruptive orbit. Ground-based observatories around the planet will keep logging every fluctuation in brightness, every irregular pulse, every fresh stream of ejected material. And somewhere in that accumulating pile of data, buried inside patterns too complex for any single observation to reveal on its own, may be the actual answer to whether Betelgeuse has thousands of years left, or whether we are closer to witnessing the end than anyone is currently willing to say out loud. What we do know is this. The star that has anchored the shoulder of Orion for as long as human civilization has looked up and told stories about the night sky is no longer behaving the way it once did. It is shedding pieces of itself into space in amounts that dwarf anything our own sun produces. It has a hidden companion physically tearing through its outer atmosphere. Its once predictable heartbeat has become erratic. And every single instrument capable of studying it in detail is being pointed in its direction, again and again, because nobody wants to miss what happens next. Maybe it happens in 10,000 years, long after every person reading this has become nothing more than a footnote in history. Or maybe, one night, without any further warning beyond the data we are watching accumulate right now, the sky above Orion changes forever, and an entire species looks up to witness something no human being has ever truly seen with their own eyes, a star, 640 light-years away. ending its life in front of us, in real time, in full, unmistakable view. Nobody can tell you when that night arrives. Nobody currently alive may ever see it. But the data being gathered today, quietly, patiently, one observation at a time, might already be building the timeline that eventually answers a question humanity has been asking since it first noticed that reddish star flickering strangely in the shoulder of a hunter frozen in the winter sky. Is Betelgeuse simply going through another chaotic phase in a long, turbulent life? Or are we, right now, watching the opening chapter of the final act?